Okay, so this is a little bit involved, this whole lighting scene thing that we're going to set up here, and I was going to go through it and do it off camera and then actually go on camera and explain everything, but I want to just read this, kind of go through it and do it all on camera, even if it takes some time, because it's involved. So yeah. So it says the first thing we'll need is a vertex shader to draw the container. Vertex positions of the container remain the same, so the code should be nothing new. Let's see, what was this? Not found. Okay. There's some source code. Okay. Draw the container. So we already have that. Our vertex. There's the fragment shader. Saved it. So the vertex shader is right here. Okay. We have location, normal, texture coordinates, model view projection, all that, texture coordinates. Okay. That's the vertex shader. The fragment shader is right here. Texture coordinates, boom. Okay. So the program actually does this right now. It has the cubes. You can move around with WASD, which is actually, this is a good basis for a 3D world, which is really awesome. So we're going to keep working on this and playing around with it, experimenting, and then, excuse me, then we'll turn it into a 3D world playground. Okay, so stay tuned for that. We're talking about the next month or two. I would like to have a 3D world to play around with and a 2D platforming, several of them to play around with. Okay, but for now, okay, so we have that. Make sure to update your vertex data and attribute pointers. Vertex data, attribute pointers. So that's right here. See, we're only using vertex attribute pointer location 0 and 2 indicated by right here, and then of course right here where they're enabled. Okay, so in the vertex shader we're only using position and text chords, position 0 and 2, even though 1 is defined. Okay, that's the normal. We haven't gotten to that yet. We can add that in later. Okay, because we're also going to create a lamp cube. We want to generate a new VAO specifically for the lamp. We could also represent a lamp using the same VAO and then simply do some transformations on the model matrix. We could also represent using the same and then simply transform that. But in the upcoming tutorials, we will be changing the vertex data and attribute pointers of the container object quite often. And we don't want these changes to propagate to the lamp object. We only care about the lamp's vertex positions. So we'll create a new VAO. Okay. So I don't think I've done this. So because there's only just the one. See, here's all this initialization stuff. Okay. The vertices, cube positions, the VAO, the VBO, okay, and then we're in the game loop. And we define the texture, then we're in the game loop. So let's create another VAO right here. Just call it lamp VAO. Okay, is everybody okay with that? Are you good? All right, unsigned int light VAO. How about glue int, GL uint. Okay, lamp VAO. Okay, don't talk back to me. No. Gen vertex arrays, GL gen vertex arrays 1 light VAO. VAO. Gen vertex arrays 1, oh, lamp VAO. We better change it to light. So that everything makes sense. Oh. Okay, GL bind vertex array light VAO. Okay. So generate a vertex array, bind the vertex array so we can work on it. Okay. This creates one and puts the actual address of the vertex array in LightVAO. Okay. We only need to bind the VBO. The container's VBO's data already contains the correct data. What? Oh, so we're borrowing the vertices of the other container is what we're saying. And the VBO from up here already has the vertices data, okay? So we're just going to use the same vertices data. We use and I'm crazy. I'm not sure this is going to work. Set the vertex attributes only position data for our lamp. Only position data for the lamp? Doesn't that seem very unlampish? Set the vertex attribute position. What? 0. Okay. And then what? What? Enable vertex attribute array 0. Oh. What's the difference between array attrib and attrib array? What the hell? What's happening? No. I don't understand. No. Okay. I think that works. I mean, doesn't it? Because these all use the same vertices, and then there's cube positions that draw the cubes in different... Okay, I don't know. The code should be relatively straightforward. Now that we've created both the container and the lamp cube, there is one thing left to define, and that is the fragment shader. Okay, but I haven't actually created the lamp as far as displaying it yet. Okay, so we just have the containers right here. Okay, there is no lamp. Okay, now the code should be really straightforward. Now we have created both the container and lamp. There's one thing left to define, that's the fragment shader. Okay, blah 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 blah. Oh, set the fragment shader for the lamp. Object color, light color. The fragment shader accepts both an object color and light color from a uniform variable. Here we multiply the light's color with the object's reflected color. Regarding to click in, this shader should be easy to understand. Let's set the object color, the last section's coral color with a white light. Don't forget to use the corresponding shader program first to set the uniforms in their place, of course, when you do it. Okay. One thing left to note is when we start to change vertex lamp. One thing left to note is that when we start to change the vertex and fragment shaders, the lamp cube will change as well. This is not what we want. We don't want the lamp object's color to be affected by the lighting calculations in the upcoming tutorials, but rather keep the lamp isolated from the rest. We want the lamp to have a constant bright color, unaffected by other changes. This makes it look like the lamp really is the source of light. To accomplish this, we need to create a second set of shaders. Okay, so first he's setting you up with the light VAO, and then he's setting you up with the fragment shader for the actual... Yeah, so he's bouncing back and forth here a little bit, but that's all right. Second set of shaders that we'll use to draw the lamp, which is what we were just working on, and then until we swatch it. Anyways, all right. I'm fine. Thus being safe from any changes to the lighting shaders. The vertex shader is the same as the current vertex shader, so you can simply copy the source code for the lamp's vertex shader. The fragment shader of the lamp ensures the lamp's color stays bright by defining a constant white color. And I discovered that I've actually got this L fragment shader, which does that. And I've got this L vertex shader, which does that. Just the position. See that? Look familiar? Okay. And that's all there is. So I've already got that. Okay, so the main purpose of the lamp cube is to show where the light comes from. We usually define a light source's position somewhere in the scene, but this is simply a position that has no visual meaning. To show the actual lamp, we draw the lamp cube at the same location of the light source. This is accomplished by drawing the lamp object with the lamp shader, ensuring the lamp cube always stays white regardless of the light conditions of the scene. So let's declare a global vector3 variable that represents the light source's location in world space coordinates. We then want to translate the lamp's cube to the light source's position before drawing it. We'll also scale it down a bit to make sure the lamp isn't too dominant. So much work. Oh my god, I'm breaking a sweat here. So you're telling me there's a chance. No. Our shader.use, all that, and that draws all the individual cubes. Okay, so let's see it work again. I'm incredibly skeptical about this. And I know I haven't changed anything. Okay, so I'm just thinking in order to get those, I'm going to see if I can get a little bit more room over here. In order to get the shaders to work, we actually have to do this up here. Where's the shader initialization? Right here. So let's go this shader, light shader, L vertex, shader.text, L fragment, shader.text. There. Is that the actual name of them? Yeah. And yeah. Okay. So then it's called light shader. We can do that. Make sure it compiles. Okay, so we actually have the other shader. That's kind of cool. Okay, so let's declare a global vector3 variable that represents the light source's location. Okay, I mean, I can do that, right? I don't want to do that. Okay, global vector3 variable. Come here. Global vector3 variable camera position. Oh yeah, we have a camera. I forgot about that. Forgot about that. Oh. Okay, light position is in place. We have the light position. We then want to translate the lamp's cube, we do, to the light source's position before drawing it. Oh no, I knew this would come up. I knew it. We'll also scale it down a bit to make sure the lamp isn't too dominant. Well, what if we are submissive and we want a dominant lamp? Okay, I didn't say that. So what is this? Model GLM mat4. Oh, that's a matrix 4x4. Okay. Model equals GLM translate model, comma, light position. Oh. Model equals GLM scale model GLM vector3. Oh, 0.2, 0.2, 0.2. Oh. Huh. Okay, I can do that. I can deal with that. We're going to translate the lamp cube. So is this just done once? I think it's just done once. That's in your initialization. So let's just go here. Let's put it right here. Model equals. Oh, wait a minute. Did we F this up already? Why is model not jiving? Jive ho! Uh-oh. I also think I just called somebody a hoe. Yeah, there's the model. So, okay, the model is a matrix 4. So, don't know why that's in there like that, but here. Source code. Let's look at this again. Camera, first mouse, delta 4, light position, okay. Main, Apple, okay. Loader, fail, can you guys read this? Okay. Depth test, lighting, shader, oh, good, okay, vertices, VBO, cube VAO, cube VAO, light VAO, okay. Where's the, model stuff? GLM map 4. Oh, it's doing it just the opposite way. Okay, I'm a little confused, but oh, it's talking about when we go to actually, oh, okay. Render the cube. So this is the actual cube that gets colored, and that's the first thing that's rendered. Hold on, so we're not going to put this in your initialization. Take that out. Jeff, you know what? What are you doing? You doing putting that in there like that? Okay. So first of all, calculate the frame, do movement, render color, clear color, activate texture. All this. We're not going to use the second texture. We can take that out for brevity. Activate the shader, camera view transform, projection. Get the uniform locations, pass the matrices to the shader. Pardon me. So there's the shader being used. Pass the matrices to the shader. Bind the vertex array. Do all this for all the cubes. Okay, so then it's right here. Is this? Okay, hold on. Because in your source code here, use, where does it bind the VAO? Bind vertex array cube VAO, draw the arrays. And then before it draws the next one, it doesn't unbind, it just binds the next one. Okay, that's fine. So let's save that for the end. And right here is where, oh, can we just, yes, that's where you want to put it in. Okay. See, GLM map for model, because it's inside that little block, so we need to make another one. Let's just go like this, GLM map for model 2. Okay, now leave me alone. Model 2, model 2, model 2, model 2, da 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 da. See, now everything's fine. We use the model 2, you know, just like the Model T, the Ford car, okay. Model 2, so we get our translation in there using the light position. We get the scaling in there using the 0.2. Okay, so this is setting transform matrix for light cube. Okay. There we go. We made it. We made it. So we're actually down here. See lamp shader use, projection view, model. Oh, this could be a problem. Let me look. Do we do that up here? Cube position, model, translate equals model, angle equals that, rotate, uniform matrix for VF, model location, value pointer model gets fit in there and then draws the triangle. So translate is in there, scale is in there. We don't need the angle, the rotation. So what we just need to do now, uniform. Okay, so in the actually right in here. Yeah. So what is it? Our light shader.use. Okay, there we go. Use light shader. Okay, so then we need to send, because we're using the shader. Okay, hold on. Pass the matrices to the shader. View and projection. But in the L, model view projection. Okay, so it's waiting for that. So we need to put that in. Okay, so we need to do this because we're going to send, and this we've already got declared, so we don't need to redeclare them. We need to do this in the light shader instead of our shader. We're going to use light shader, model view projection. So we're just changing those variables. We're updating them with the light shader information. Get the uniform locations. Okay. Then although it doesn't really look like we really use okay, and let's just go ahead and pass the same view and projection matrix in there. Okay, so new shaders, but we're going to pass the same variables for view and projection. The model we're going to do separate right now. GL uniform, oh my god, get that out of my face, matrix for FV. I know, I'm quite testy. I worked today for 8 hours and I don't know, I'm in a testy mood. Sorry. Model location 1, GL false, whatever that is. GLM value underscore pointer model 2. Okay, this time we're using model 2, light cube, pass the matrices to the shader. A lot of work just for a cube, isn't it? Well, it is, but you know what? Those darn cubes, they're worth it. Okay, so pass the model. See the view and projection. So we're doing all this right now. All this right now. Oh, I didn't know we could do that. Well, I think that's part of the. It's part of the shader. No, wait, I'm confused. Shader class. Where is that? Oh, good lord. Good lord. Mr. Clean, Mr. Clean. Shader class. Shader class. There's only shader class 2.h. The heck's the other one? I don't know. I'm confused. I'm so confused. Where is this? Can you open this for me? Open document. Oh, thank you. So program shader, okay. Use, and that's it. So there isn't a, yeah, okay. What I was looking for is this function right here, set mat4. It's just an encapsulation for what I did. It's just, oh, go back, no, or yeah. So instead of this right here, it would just, or this right here, what I just did, it would be set mat4 and then the variable. Anyways, moving on. So then bind vertex array, draw triangles. Okay. All right, you know what? I'm down for that. Bind vertex array. Good grief, why do we do these things? I don't know. Bind vertex array. What's the vertex array? I've forgotten already. It's been so long. It's been such an ancient time ago. It's in the past. Oh, bind vertex array light VAO. How quickly we forget. Quickly we forget. Yes, there. And then what you're telling me is draw arrays. Yay. Okay. Can we be done now? Can we be done? I'm a little bit skeptical about this, but let's give it a try. Compile and run. Uh-oh. So does anybody see the lamp anywhere? It looks like it's right there. What is it though? Look at it. That is one funky looking lamp. wonder why that is. You know, it's good enough to indicate the location of the lamp. Why it's not a cube is kind of making me wonder right now. Let's look at the VAO for a second. I think it might be there, although I have to. The VAO. Oh, right. Excuse me. So the VAO is not like this. Where did I get this? Oh, from the code. Okay, so because each one's 5. And then now it should be better. Go back, go back. Redo, redo. Where is it? Where is it now? Show me. There it is. Okay. If you don't do it right, you're not going to do it. So, okay. So I hope everybody caught on to that. It was the stride in my vertex attrib thing that was off. That's the official term. It's a technical term. It was the stride in my vertex attrib pointer function. Okay? Okay. Gosh, I feel like I just gave birth. Okay, what's next? Not really much to look at right now. Well, then why did I do all that work? No. Okay, if I have difficulties in the code snippet, having a fair bit of knowledge because basic some sexy lighting stuff. Ooh, jump to the next tutorial where the real magic, the sexy lighting magic begins. Stay tuned for that, ladies and gentlemen. Well, we just did the setup. Okay, that was I feel like I gave birth, and we're going on 27 minutes. So thank you for watching. Be sure to like and subscribe and leave comments in the section below. And stay tuned for, yes, probably part 2, 3, 4, and 5 in this one because it goes on and on.